In this EcoWest presentation, we explore what the science is telling us about climate-driven trends in the western snowpack. Across the West, observations show a general trend towards rising temperatures. Over recent decades, there has been a 1 to 2% decline in snow per decade, with greater impacts seen at lower elevations, which tend to be more sensitive to temperature-driven changes than colder, higher elevation regions. Currently, the most significant loss of snowpack occurs in April and May, but is nearly absent during February, when temperatures are usually far below freezing level. Given projections of increased temperatures in the coming decades, many scientists predict that we will see an earlier onset of snowmelt and a reduction in late-season snowpack. The most significant loss of snowpack has been observed during the mid to late snow season. This figure shows trends and changes in monthly snow water equivalent values for February through May. As you can see, most stations accumulate snow from February to April and then lose snow during April to May. With rising temperatures in the near term, locations at lower elevations that are more sensitive to temperature change may experience earlier snowpack loss. Scientists have used models which predict a decrease in spring snowpack and a transition to more precipitation in the form of rain across the West. The figures above show the mean winter temperature according to various models, both during the 1960 to 1999 time period, and the projected change during the 2006 to 2039 period. The largest increases in temperature influence are projected in the Sierra Nevadas in California, the Cascades in the Pacific Northwest, and northern Rocky Mountains in Idaho and Montana. This figure shows a transect of snow course locations in California, Washington, Oregon, and British Columbia. The trend line shows a general decrease in April 1st snow water equivalent as elevation declines. An important implication of this figure is that spring snow water equivalent will grow increasingly sensitive to temperature. As temperature follows an upward trend in the upcoming decades, the warming effect is poised to impact the snowpack, even in higher elevations. Snowcaps are natural reservoirs for water supply in many areas of the West. Hetch Hetchy Reservoir in California, for instance, is replenished with snowmelt from the Sierra Nevadas, and the water supply is eventually transported to the taps of San Francisco Bay Area residents. If snow melts earlier, as climate models predict, critical water supply infrastructure like the Hetch Hetchy Reservoir and drinking water for entire urban centers could face serious threats. A world with warming temperatures is poised to trigger more potent blizzards. Since a warmer atmosphere can hold more moisture, it is reasonable to expect an upward trend in extreme winter precipitation, in the form of both rain and snow. During the past 50 years, the U.S. has seen twice as many of the most extreme snowstorms as compared to the previous 60 years. For more resources about environmental trends in the West, please visit ecowest.org.